Bill Zahner, CEO and president of Zahner Company, fourth generation owned metal engineering and fabrication firm. With more than 120 years of experience, Zahner specializes in creating some of the most remarkable metal surfaces ever constructed. Mr. Zahner received his Bachelor of Science degree in Civil Engineering from the University of Kansas. He is the author of 2 books on the use of metal in architecture and art, and has contributed to numerous articles and books on metal restoration and fabrication. He has received the 2017 Distinguished Engineering Service Award by the University of Kansas. He was inducted into the Entrepreneurial Hall of Fame by the University of Missouri and received the Ernst & Young Regional Entrepreneur of the Year Award for Engineering. In 2007, Bill was awarded an honorary AIA from the American Institute of Architects. In 2006, he received the prestigious Copper Medal Award by Associazione Italiano di Metallurgia. And Mr. Zahner has also served on the Manufacturing Advisory Board to the U.S. Secretary of Commerce. So join me in welcoming Mr. Zahner.
Try and have a lot of fun. Here we go. But I start out with this whole kinetic art thing as a question of balance. And we've had the opportunity to work on several kinetic sculptures over the years. And the one thing, from an engineering standpoint, that we find, a lot of it deals with this balance issue. And I have a quote from Alexander Calder, and I love the idea of a detached body floating in space. So some of the work that we get involved with on the kinetic side, on the art, is the way it moves, and so it's the part that intrigues us as humans, this very gentle movement and flow. And we've had the opportunity on this was a real early one. We worked with an artist, Joyce Ferny. It was a project out in Fort Hays, the hospital in Fort Hays. Fairly large piece, and it's a series of plates of material, some even mica plate things, but we recognize quickly, the balance is so critical, and it almost becomes deceiving, and I'll get to that point in a moment. And a lot of things we work in, as engineers and fabricators, we really don't want them to move. We kind of want them to be stable and stay, And this art piece we did for an artist, Jan Hendricks, down in Mexico. And it's a tobacco leaf, a series of them. They're water jet cut, but it's like a smoke ring up through the middle. But, we have to design these because Mexico has earthquakes, things shake around, and how are these going to stay but look like they're just floating in space, these objects? Another one we worked with Jan on was this gallery exhibition in Mexico City, and it was a series of these pieces that were laser cut out of copper alloy, and then we chrome plated them. And we chrome plated them so we could obtain this reflective aspect, and I'll see if I can pick it up in a minute. But they're all kind of hanging in space in the gallery. They're about 15 feet in length. You can see the fine laser cut lace, and before, several years ago, you couldn't cut that fine of work in copper alloy in particular with a laser, and we have a monster down in Texas that we're continuing to pay for making art with, I hope, where we cut the pieces out. But the way light shimmers from these, the way the light hits the pieces and moves is one of the beauties. And they're hanging there, so people are coming into the gallery space, and I'll see if I can capture a little bit here.
En el fondo es la forma más sencilla, ¿no? Que es un alga
super
simple.
But they're shimmering. Let me get the volume down on this. Maybe it'll work. Another one you can see where...
También, ¿no? Que tenga otro tono. A lo mejor esa es negra y esa es cromada, no sé.
I don't know what he's saying. He's probably complaining that we cut one wrong. But you can see they're like alive. And you walk through, the beauty is you're walking through the space, and just the air from your body, the people walking through it, makes them just gently move, and the reflectivity of the material just, I felt like I was in the ocean, you know, these things just gently waving and moving in space. But again, you know, we design these things or work with the artists in designing and engineering these pieces to, a lot of times, to hang over the head of people. And they can get quite heavy, pieces of glass and things that we're trying to make so they stable up here, these beautiful pieces of art, and they have to be there forever. You know, so we have to design them and engineer them to work in a way and balance in a way. And the tricky part when you get into these is, you know, you see these, and we saw the art, or some of you saw the art, the kinetic art that the artists put together out at the arboretum, but they're so gently moving because of the balance they're in. And that balance is constantly changing. And when we were fabricating some of these pieces, sometimes when you get them in balance, you kind of forget that there's a lot of weight there. And our workers, and I remember one time we were working on one of these pieces for Derek Van Keppel. This is at Shawnee Mission Hospital, this particular piece, but you know, that one of the guys says, well, we need to undo this, and he unhooks the one side. It's just kind of floating there. He's up on his lift, unhooks the other side, and just bam! You know, immediately everything shifts. It's sort of like gravity event, you know, just grabs that thing and takes over. So on this particular one, because we had all these little glass baubles hanging in different areas, you know, I pointed to the artist, I said, what if one of those breaks? You know, are we going to have a calamity? And so what we have inside of these, we started out, we put sand inside them, you know, to kind of balance, use this to help balance it out. But I said, but if it breaks, the sand comes out, it still does it. So we ended up putting the sand in bags. So inside some of these, there's like bags of weights, so that if something was to happen, it's not going to change. But it's this illusion of this lightweight piece. That's what the art tries to achieve. And they move in gentle breeze. They're on, you know, fishing tackle is a big thing, you know, because you get these little swivel things, so the fish, when you catch them, wiggles around. The trouble is we got to get fishing tackle that's rated, you know, for engineering forces. And another one. Some of the trick, you know, is to make these things just kind of hang gently in space and maybe move from the air currents. This is a beautiful one for Jason Poland and that we worked on. It's about 15 feet tall, and they just gently move. Now the trick on this is made of metal that he's painted. The trick on this is the lower piece that's made, you know, has a very minor load. It's a small load of the last piece. The one at the very top, the connection has got the full load when you do these vertical hanging pieces. This is one we were working with an artist, Riccardo Regazzoni, in Qatar, and he wanted to make these 40-foot long pieces like jewelry hanging down from the ceiling. And so here we are in our factory. We're putting together, the blue is a protective paint or protective film. It's aluminum. And one thing, we had to make all this kind of connect together. So really the connection's here. It's just holding this one piece. But the connection up here is holding the whole piece. But we have to make them work together and look correct. And I didn't really want to weld them. Aluminum's kind of tricky to weld from a strength standpoint, but we also wanted to make it so it disappeared. So we came up with ways where we milled out the center of a 5mm thick aluminum plate and came up with these little pieces that we could put in there. And we tested it, you know, pull things apart and see if they break and how they break. But we're building these like this, and we got to get them like this. So the other part of what we're doing is checking to see how do we raise them up. This is one of our engineers. We created this thing we call a Stromback that you hook on, so we could raise these 50 some odd pieces up into position. And the idea from the artist, he wanted to bring light down from the skylight and bring it into the space and have them shimmer. And the owner said, well, can we make them move too? Let's just have them shimmer. And so there's a series of these. They're beautiful pieces, like jewelry hanging down from the ceiling, but they're engineered to be there for eternity, because you know, we have to make sure that all the connections work. It's a beautiful little spot. It's sort of like, again, you're at the bottom of a kelp field in the sea. And out here, we had the honor of working with Leo Villareal on this great piece. And he was in, he had brought, we made all the stainless steel panels, and he brought in all his guys, and they're putting together the light pieces in there. They're all little diodes, and we're testing them. And I go, what are you really making? And so when it put in place, it's beautiful. There's a little error right here. The metal worked, but it's a beautiful piece. And so here's kinetic using light to move the pieces around. And in other ways that to make them move or appear as moving, we worked with Disney on their Animal Kingdom. We made these giant creatures. This is a butterfly, and they use water pumping through it to make the wings look like it's moving and actually move parts of it. And then other ones had giant lizards that spit water at the butterfly, and you can see in the back the tails like wiggling, done with water. And then giant fish. These are stainless steel, and we had to make them so they floated in the water, but the part that's floating them is just underwater. So I kept telling the engineers at Imagineering, I said, when you try and get something to go underwater, it continues to go underwater. So there's this weird balancing effect we had to arrive at. But you can hear the movement is generated by the water and gives this illusion. It also, the wind moves the pieces as well. Another one here in Kansas City on Troost, the art that they're trying to add throughout the city, which is really wonderful. And Matthew DeHamer is a pretty good friend, and he produces these great moving pieces. The bus pulls up and the thing folds and moves, and they're very they're controlled by mechanics. And the mechanical end of it is really tricky as well, because again, you're changing center of gravities, you're doing different things, you're putting things that can wear out into them. So, we get into some of these. This is another fun piece from a local artist, Laura DeAngelis. I think she went to the Art Institute as well. And this is celestial flyways. So we made these stainless steel pieces that they sunk in to the concrete, and we hope they don't move. And then she had this great disc form that she remodeled the constellations, and she drew them in different fashions. They were quite beautiful. And here's this disc, and at the opening, you could come and look at it. And here's up close. You can see the different constellations. It's blue stainless steel. We etched the metal to make the pieces come out. So the blue stainless gets its color from light interference, so the color doesn't disappear. It's not a dye or film, but it's from growing an oxide film on it. And here's it. You can kind of see the movement of the piece. I don't know what this character comes out here. Now, so it gets installed. I go down and look at it the first day, and there's a dog on it. And this lady's like pressing the button, and the dog is, and I'm like, that's a piece of art. Oh yeah, it's wonderful. My dog really loves it. And I'm like, Another one that we were involved with, Larry Young, and he's got some fantastic pieces. I love his patinas. They're gorgeous pieces. And this one was at Stowers Institute, fairly monstrous form. We had to make it. In Kansas City, we do a lot of barbecues, so we move these things on barbecue things. So we put them together. It helps us. And then deliver them on the same barbecue deal, and then install them. But the owner wanted to move. And first he said, I want it to move 4 times an hour to a circle. I'm like, that's a lot of dynamic momentum we're putting in this. So we had this little motor underneath. It was just, I said, let's do it maybe four times a day. Make it move very slowly. The other tricky part with anything that's open to the public that's a movement piece is you can touch it, or you can go up to it, so you got to have things that stop. And because you don't want to get, you don't want a bunch of kids riding it, and then you also don't want it to do much. This artist, Chuck Hoberman's a good friend, and we've done a number of pieces with him, and these are his spheres. And Chuck was the one who invented that toy, the Hoberman sphere. And so he kind of makes some other Hoberman spheres out of metal. But he's a genius in the movement of the pieces and the way that the mechanics work, and understands really well that we want mechanics that don't require a lot of maintenance. So you have to have the stress levels really reduced in these. So we got with him and we started making these things we called Tessellate Walls. And the idea was to have, initially it started out adaptive, so they'd move, so you'd cut out light into spaces or you change it. And I said, Chuck, no one really wants to buy it for cutting out light. What they want to do is buy it for the art because they look so beautiful and the elegance. So we started working with him on different pieces. Here's, you can see how we hide the actuator and showing how it moves. And it's a very simple, straightforward piece. And these are some really early ones that we'd created. And so there's a series of metal plates that by the actuators kind of making them shift around. And what happens is these are all symmetrical designs, so the designs constantly change and move and modify. It could also be a giant cigar cutter. We're looking at ways of using these. But you can see the designs change. So the first people that wanted, they said, we really like this. It was the nuclear or physics place up in SUNY. And so we put in these ones here. And we put them in glass. Let's see if I can get them to move here. There we go. And it became more of in this case, more of a piece of art as they function, to change. And they're beautiful. These are all very, very symmetric, but the designs constantly change. You can put them on an actuator and control it so they move gently. But it's almost an organic feel. It's almost, for me, it's almost like, there's Chuck right here. They're almost the way a crystal grows. You see these rapid images, and see if we get a close up here. But they move in real time, and you can control that. You can use them to shade if you want. But we started finding all these patterns, and the beauty of the computer today is you can mock these up. You can check different things. You can modify how they're going to interrelate to one another and test them. But the movement is so gentle. There's only one actuator, and it just pushes. This goes this way and this way. And then just in the process, it causes these little things just to rotate just slightly against one another. And we started building up many more thicknesses, and I think these have about 3 or 4 plates to them. But they're expensive because there's a lot of metal with a lot of holes. More holes or more nothing, it gets more expensive. So we started looking, and because they're expensive, here's just kind of testing out. The Saudis saw what we were doing, and they have a lot of money, and so they said, well, we want to create these pieces for a facade, and so working with Chuck and wanting to break the symmetry because a lot of the pieces were symmetrical, and we said, well, let's make it a little different. So these are titanium skins, and you can see this is a mock-up we did in one of our plants to show one of the guys from Saudi Arabia comes in and looks at it. But make it, he could make it look like rain and waves, but by breaking the symmetry, the other ones being very symmetrical in their movement, this then became more like growing a tree. And fortunately, I don't have the movement picture of this one, but it's really very subtle. Another one, we were working with Chuck on this. This is a nutty project in Japan, where again the movement, the Japanese client wanted to be able to press a button and have everything disappear up or come down and close in the opening. But you can see it goes tighter than open, so it's this wave form that you get in the movement of pieces. And so we mocked this up in one of our buildings just to see if it would work. Final one I'm going to show you is a project we completed a year ago, and it was for Anthony Howe. And it's a beautiful piece. You know, we do all the generation of the form in rhino, in this case, and then we move it to our CATIA elaboration, figure out how the movement's going to work, how the structure, we had to design this to resist hurricane loads going to Florida for a collector down in Florida. And it was a beautiful piece of these copper plates. Everything had to be designed for 120 mile an hour wind. And it did go through the latest hurricane, my understanding. But we made it out of bronze and stainless and these patinaed copper plates. And it, you know, all the pieces had to be balanced to move in the wind. The first place that, you know, client put it in was back in the bushes, and it didn't move. And I said, well, he has to have wind. And so we moved it. He had us move it to the front, and now it's got too much wind. But it was a fun piece to work on, and really, you know, working with the different metals and working for artists is really the joy that we have. And it's such a challenge and a heck of a lot of fun. But I look at the work that you all have out in the artists have out in the arborarium, and seeing how they move and they, you know, with the wind, you know, it's really a question of balance. But thank you so much for the opportunity to talk.